In 1898, inside a converted shed behind the Paris Medical School, I held something that glowed in my hands. There was no flame, no electricity, no chemical reaction. Pure radium was shining by the light of its own atomic transformation. My name is Marie Curie, and I would eventually receive 2 Nobel prizes, becoming the only person in history to win in 2 different sciences. But on the night I first saw radium glow, I knew only that I was holding something that should not exist, according to everything physics had taught us about matter and energy. What I discovered about radiation should disturb everything you think you know about the world, not because radiation is dangerous, though it can be, but because of what radiation reveals about reality itself. You are radioactive right now. The potassium in your cells is emitting particles as you hear these words, and cosmic rays from distant stars are passing through your body at this very moment. You have always been radioactive, from the moment you were conceived until the moment you die. Your fear of radiation is not a fear of something external. It is a fear of understanding what you already are. Most people cannot explain what radiation actually is. They know it is dangerous. They imagine invisible beams of death, accidents at power plants, the terrible aftermath of weapons. They nod when someone mentions the word, believing they grasp what it means. But ask them where radiation comes from, what produces it, why certain substances emit it and others do not. They cannot answer because they have never truly asked. They accept the phenomenon without demanding to understand it. This is not science. This is superstition dressed in modern clothing. When you truly examine what radiation reveals about matter itself, you discover something that should unsettle your assumptions. Something that transformed not only my understanding of physics and chemistry, but my conception of what existence is made of. Consider what everyone believed about matter at the close of the 19th century. For 2,000 years, humanity had accepted that the atom was indivisible, and the very word comes from the Greek atomos, meaning uncuttable. Scientists treated the atom as a tiny solid sphere, a given, a foundation. Chemistry explained how atoms combined, while physics explained how they moved. But the atom itself simply was eternal, unchanging, indestructible. In 18 months, working in a shed with a leaking roof, I would prove that atoms transform, that they emit particles, that they change into other atoms entirely. In 18 months, I would prove that atoms die. It began with Henri Becquerel, who had been studying phosphorescence at the French Academy of Sciences and examining whether uranium compounds might emit rays similar to Wilhelm Röntgen's newly discovered X-rays. Röntgen had already won what would become the first Nobel Prize in physics for those X-rays, which could photograph bones through flesh, and the scientific world was captivated. Becquerel wrapped a photographic plate in black paper, placed uranium crystals upon it, and set the arrangement in sunlight. The plate became fogged, which he expected, because he thought sunlight was exciting the uranium to emit rays. But then came cloudy days in Paris. Becquerel placed his wrapped plate and uranium crystals in a drawer to wait for better weather. And when he developed the plate days later, out of mere curiosity, he found it was fogged anyway. The uranium had affected the plate through black paper, in complete darkness, without any exposure to sunlight whatsoever. The greatest discoveries often begin with weather delays and impatience. Think about what Becquerel had observed. The uranium was emitting something constantly, without any external source of energy, without light, without heat, without electricity. The emissions seemed to arise spontaneously from the uranium itself, as if from some internal and inexhaustible reservoir. This was the mystery that captured my attention, this constant spontaneous emission. Where was the energy coming from? And how could a substance pour out rays endlessly with no apparent fuel? Everyone else remained fascinated by Röntgen's X-rays because they were spectacular, immediate, and useful for medicine. Becquerel's weaker uranium rays were largely ignored, but I was drawn to this neglected phenomenon precisely because it posed a deeper question, and the spectacular often blinds us to what matters more. At the Sorbonne, the University of Paris, where I was only the second woman ever to earn a doctorate, I began systematic investigation. I measured precisely and methodically. The instruments were exquisitely sensitive, including an electrometer that could detect the faintest electrical currents. Radioactive substances ionize the surrounding air because the rays knock electrons loose from molecules, creating charged particles that carry tiny currents. By measuring these currents, I could measure radiation intensity with far greater precision than photographic plates allowed. I tested uranium in every form I could obtain, including pure metal, oxide, sulfate, and chloride. I dissolved it in solutions and combined it with other elements, measuring and recording over and over again. What emerged from these measurements was unexpected. The radiation did not depend on the chemical state of the uranium. Uranium oxide radiated in proportion to its uranium content, and so did uranium sulfate, and so did uranium chloride. It made no difference whether the uranium was combined with oxygen or sulfur or chlorine, no difference whether the compound was powder or crystal, wet or dry, in light or darkness, hot or cold. Stop and consider what this means. Chemical properties depend on how atoms bond with other atoms. Burn wood and you change its chemical structure so that its properties transform dramatically. But the radiation from uranium ignored all chemistry and persisted through every transformation. The uranium could be dissolved, precipitated, heated, cooled, combined, or separated, and always the radiation remained, proportional only to the amount of uranium present. This led me to a hypothesis that seemed almost reckless at the time. The radiation must be an atomic property of the element uranium itself, not a property of uranium molecules, not a property of uranium crystals, but a property of uranium atoms. Something was happening inside the atom. Something the atom was doing entirely on its own. If radiation was an atomic property, then the atom was not the inert, indivisible sphere that science assumed. The atom was not static but active. It was transforming. I tested every element I could acquire, every known substance, one by one. Thorium also emitted these rays, and here was a second element with the same atomic property. I needed a term for substances that emitted such rays from their atoms. I called it radioactivity, from the Latin radius meaning ray, and I invented this word. Few scientists get to name the phenomenon they discover. This word has since become associated with destruction and fear, but what radioactivity actually reveals is that atoms are not dead matter. They are not tiny billiard balls sitting inertly in space. Some atoms are transforming, emitting particles, changing into other atoms entirely. The supposedly indivisible foundation of all matter is undergoing internal metamorphosis. Ernest Rutherford, the New Zealand physicist who would later use radioactivity to discover the atomic nucleus itself, called this the most important discovery since humans learned that matter was made of atoms at all. The ancient dream of the alchemists to transform one element into another was happening spontaneously in nature, inside every radioactive atom. But the mystery deepened. When I measured radiation from pitchblende, the ore from which uranium is extracted, I found something that made no sense. The pitchblende was 4 times more radioactive than could be explained by its uranium content alone. 4 times is not a small discrepancy, and not a measurement error. Something in that ore was radiating far more intensely than uranium itself. There was only one logical explanation. Pitchblende must contain another element unknown to science that was more radioactive than uranium, an element present in such minute quantities that no chemist had ever detected it, but so intensely radioactive that even a trace made its presence unmistakable. And that's when radioactivity became a method for discovering new elements, not by weight, not by color, not by chemical reaction, but by radiation alone. We could detect substances too small to weigh, too small to see, too small to analyze by any ordinary means, and the electrometer became our instrument instead of the balance scale. We had entered a new kind of chemistry, a chemistry of the imponderable. My husband Pierre and I began the work of separation. We obtained pitch blende in quantities measured in tons, dissolved it, precipitated fractions, tested each fraction for radioactivity, separated the radioactive fractions further, and tested again. This was not glamorous work. Picture the shed, a converted dissecting room behind the school where Pierre taught, poorly ventilated, with a glass roof that leaked when it rained and baked us in summer. The only furniture consisted of worn pine tables, and we had no proper shelter for our products, no funding, no assistance. For days at a stretch, I stood in that shed stirring boiling liquids in cast iron basins with an iron rod nearly as tall as I was. Ton after ton of pitch blende residue passed through my hands, which became cracked and scarred from the chemicals, and my clothing became permanently contaminated. Slowly, fraction by fraction, we concentrated what we sought. In July of 1898, we announced to the French Academy of Sciences the discovery of a new element, which we named polonium, after Poland, the country of my birth that was then partitioned and occupied, erased from maps of Europe. The element exists, and so does my homeland. But our work was not complete, because even after removing the polonium, the remaining material was still intensely radioactive. There was something else. In December of 1898, we announced the discovery of radium. Here is where radioactivity becomes truly strange, truly wonderful, and truly disturbing. Radium did not merely emit invisible rays, it glowed. One of our joys was to go into the workroom at night, where we perceived on all sides the feebly luminous silhouettes of bottles and capsules containing our products. The glowing tubes looked like faint fairy lights, and it was a lovely sight, always new to us. We had extracted from crude ore a substance that shone by its own internal light, not phosphorescence, which requires prior exposure to energy, not chemical combustion, which consumes fuel. Radium glowed spontaneously and constantly, drawing on some internal reserve that seemed inexhaustible. And radium was warm, always warm. It maintained a temperature measurably higher than its surroundings, generating heat endlessly from within. Careful measurement showed radium releases approximately 118 calories per gram per hour continuously, year after year. Where was this energy coming from? Think about what we observed. A substance that glowed in the dark, that warmed itself continuously, that emitted rays powerful enough to penetrate solid matter, that did all this spontaneously with no external energy supply, decade after decade. This violated everything scientists thought they knew about energy conservation. You cannot get something from nothing, and energy must have a source. Yet here was radium pouring out energy as if from a fountain that never emptied. The hypothesis Pierre and I proposed was this. The radiation represents an emission of matter itself, accompanied by a loss in weight of the radioactive substance. The energy comes from the atom, whose internal transformation is not yet complete, meaning the atom is releasing something from within. This was verified. Radium was not merely emitting energy, but emitting particles. Alpha particles, which are helium nuclei, as Rutherford later proved, were being hurled from radium atoms at enormous velocities, and with each emission, the radium atom transformed into a different element entirely. Transmutation, the word alchemists had used for centuries about their imagined transformations of lead into gold. But this was real, and it was happening constantly inside every radioactive atom in the universe. Let me make this concrete because the implications are difficult to grasp. Radium has a half-life of 1,600 years, which means half the radium that existed when the Roman Empire fell still exists today, still glowing, still warm, still transforming. And it will continue transforming when whatever replaces human civilization is itself forgotten. Take a sample of radium today and wait 1,600 years. Half of those atoms will no longer be radium because they will have become radon gas, then polonium, then lead, transforming through a cascade of radioactive decay. Wait another 1,600 years, and half of what remains will have transformed again, and so on, down through the ages, until all the radium has become stable lead. Every radioactive element has its characteristic half-life. For uranium-238, it is 4.5 billion years, roughly the age of the Earth itself. For certain polonium isotopes, it is fractions of a second. For the americium 241 inches, your smoke detector, it is 432 years, meaning that small radioactive source will be emitting particles longer than any nation currently on Earth has existed. You live with deep time in your hallway. Atoms measure themselves in eons, while we measure ourselves in decades. We are the impatient species. This means atoms are not eternal because they have ages. Some atoms in your body are older than the Earth. The uranium in the ground has been decaying since before our planet formed, and it will continue decaying long after humanity has vanished. You are surrounded by atomic clocks ticking away on timescales utterly beyond human comprehension, and every radioactive atom is counting down to its own transformation. Here is what troubles most people, what lies beneath their fear. These rays, these particles, pass through solid matter. Alpha particles penetrate thin aluminum foil before stopping. Beta particles, which are electrons emitted at high speed, pass through much more. Gamma rays, the most penetrating of all, traverse centimeters of lead. Your walls cannot stop them all, and your skin cannot stop them. They pass through you, and as they pass, they disrupt, they ionize, and knock electrons loose from molecules in your cells. They can damage DNA itself, the molecular instructions that tell your cells how to live. This is what people fear. This invisible penetration, this violation of boundaries we assume protect us. But remember what I told you. You have always been surrounded by radiation. Radioactive elements exist in soil, in building materials, in the food you eat, in the air you breathe, because radon gas seeps into basements from uranium in the ground. Cosmic rays from distant supernovae shower through you constantly, and you contain radioactive potassium 40 inches, your own muscles, your own blood, your own brain. The world has always been radioactive, and humanity has always been radioactive. The difference is that now we understand it, and understanding transforms everything. The same rays that damage healthy tissue destroy diseased cells faster. We observed that radium destroys abnormal growths more readily than normal tissue, and from this observation arose what is now called radiation therapy, the treatment of cancer with precisely targeted radiation. Millions of tumors that would have been death sentences have been eliminated by the same phenomenon people associate with destruction. In hospitals today, radioactive tracers are injected into patients to image their organs, detect cancers, and study their brains. Technetium-99 meters, produced in nuclear reactors, is used in tens of millions of medical procedures every year. The fire we discovered has become a tool for healing. During the Great War, when young men lay wounded in field hospitals across France, with their bodies riddled with shrapnel, we developed mobile radiological units. I call them petites, Curies, vehicles equipped with X-ray apparatus that could be driven to the front lines. Surgeons could locate bullets and shell fragments precisely before operating. And soldiers who would have died from blind, groping surgery survived because we could see through their flesh to find the metal killing them. I drove those vehicles myself into the war zones and trained 150 women to operate the equipment. We performed over 1 million X-ray examinations. The same radiation people fear saved countless young men from death on operating tables. What radioactivity reveals is not merely that the world is dangerous, though danger exists. What radioactivity reveals is that matter itself is not what we assume. The solid table before you is not solid, but mostly empty space, with tiny atomic nuclei separated by vast relative distances, surrounded by probability clouds of electrons. And some of those nuclei are unstable, transforming, emitting particles and energy, becoming new elements. The discovery of radioactivity adds new phenomena to the great number of invisible processes now known, and once more we are forced to recognize how limited is our direct perception of the world. How numerous and varied may be the phenomena we pass without suspicion of their existence, until the day when fortunate accident reveals them. We see only a narrow band of the electromagnetic spectrum, a thin sliver of visible light in an ocean of radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. We hear only certain frequencies of sound. We perceive solidity where there is mostly void, and we assume permanence where there is only slow transformation. A scientist in her laboratory is not only a technician, but also a child placed before natural phenomena which impress her like a fairy tale. We should not believe that all scientific progress can be reduced to mechanisms, machines, and gearings, though such machinery has its own beauty. The deepest beauty lies in what is revealed, that the universe is stranger and more wonderful than our senses suggest, that matter is not dead substance but dynamic process, that atoms transform and elements change and energy flows from configurations we are only beginning to understand. I am often quoted as saying that nothing in life is to be feared, only understood. What I did not add is that understanding can be more unsettling than fear. Fear is ignorance confronting the unknown, while understanding is knowledge confronting the real. I knew what the radium was doing. The same radiation that created those fairy lights in our laboratory was accumulating in my bones, disrupting my blood cells, slowly destroying my body from within. My fingertips were burned and scarred, not merely from chemicals, but from the radioactive materials I handled every day for decades. I did not fear it because I understood it. Understanding does not grant immunity, but only clarity about what is happening and why. My notebooks from those years in the shed are still radioactive today and will remain so for centuries. If you wish to read them, you would need to visit the Bibliothèque Nationale de France, sign a liability waiver, and handle them with protective equipment. They are kept in lead-lined boxes, my scientific legacy too dangerous to touch with bare hands. In the decades after my death, factory workers would paint watch dials with radium, licking their brushes to form fine points because they had been told the radium was harmless. They were called the Radium Girls, and they died horribly with their jaws crumbling and their bones honeycombed with radiation damage. This happened not from malice, but from ignorance marketed as safety, from employers who understood the danger but chose profit over truth. This is why understanding matters, not as abstract knowledge, but as the foundation for wise choices in a world where atomic processes continue whether we comprehend them or not. We must not forget that when radium was discovered, no one knew it would prove useful in hospitals. The work was pure science, driven by curiosity about an unexplained phenomenon, which is proof that scientific work must not be judged only by its immediate usefulness. It must be done for itself, for the beauty of understanding, and then there is always the chance that discovery will become benefit. The chance, not the certainty. Science reveals what is true, while what we do with truth is a different question belonging to ethics and politics and human choice. But we cannot make wise choices about what we do not understand, and we cannot navigate a world whose fundamental nature remains hidden from us. My daughter Irene continued the work. She and her husband, Frédéric Joliot, discovered artificial radioactivity, the ability to make stable elements radioactive through bombardment, and she received her own Nobel Prize for this. The fire passed from generation to generation, and the understanding deepened. If I could speak to you across the century, you who have seen Chernobyl and Fukushima, who use radiation to image your unborn children, who debate whether to bury nuclear waste for 10,000 years, I would say only this. The question was never whether radiation is dangerous. Of course it is dangerous, because fire is dangerous, electricity is dangerous, and knowledge itself is dangerous, because it enables power. The question is whether you will understand radiation well enough to choose wisely, whether you will make decisions based on comprehension or superstition, whether you will fear what you imagine or respect what you know. The unit of radioactivity now bears my name, the Curie, defined as 37 billion atomic disintegrations per second, roughly the activity of 1 gram of radium-226. Every time a scientist measures radioactivity anywhere on Earth, they use a unit named for what we discovered in that leaking shed. Ernest Rutherford once called me the greatest woman scientist who ever lived. I do not know if this is true. I know only that I saw what had been hidden, that I measured what seemed immeasurable, that I named a phenomenon and pursued it to conclusions that disturbed established thought. The discomfort that radioactivity causes comes not from the radiation itself, but from what radiation reveals, that the foundations are less solid than we assumed, that matter transforms, that energy emerges from depths we had not suspected, that the invisible exceeds the visible in both extent and importance. The atom is not a final truth, but an opening. The radioactive elements are doorways through which we glimpse processes operating on scales of time and energy that dwarf human experience. Stars forge elements through nuclear fusion, while radioactive decay powers the heat at the Earth's core, and the universe itself is a vast atomic transformation unfolding over billions of years. And here you stand, made of transformed atoms, capable of understanding your own composition, tracing the ancestry of the elements in your blood to ancient stars that exploded before your sun was born. This is what radiation means. Not danger alone, though danger exists. Not death alone, though death comes to all. It means that you are woven into processes far greater than yourself, that what appears permanent is only slow, that what appears solid is mostly void, that what appears inert is alive with transformation. Life is not easy for any of us. But what of that? We must have perseverance and, above all, confidence in ourselves. We must believe that we are gifted for something, and that this thing, at whatever cost, must be attained. The thing I was gifted for was to see, to measure, to understand, to name what had no name, and follow it wherever it led. Radiation is not what you thought. It is not merely danger to be feared or power to be wielded. It is truth to be understood. The truth that matter itself is transformation, that beneath the surface of the seemingly solid world atomic metamorphosis proceeds without ceasing, that you yourself are part of this ancient process, this fire that burns at the heart of things. And now that you understand more, you will fear less. Now that you understand more, you will wonder more. That would be enough.